Hello and welcome to today's webinar on the 510K and substantial equivalence. Why do so many get it wrong? My name is John Spear and I'm the founder and VP of Quality and Regulatory at Greenlight Guru, and I'll be the moderator for today's event. We've got a really special presentation scheduled for you today. I know our presenter, Dr. Michael Drews, is really looking forward to sharing his thoughts and experience on substantial equivalence and how you can use it to your advantage. Before we dive too deep into today's presentation and introduce our presenter, I'm going to touch on a few items real quick. First, today's webinar is going to run for about 90 minutes in total and will include a Q&A session at the end where Mike has been kind enough to stick around to answer many of your questions. So I would encourage you throughout the broadcast today to submit your questions as they come up in the box on the right-hand side. And as I mentioned, we'll get to as many of those as we can at the tail end of today's session. Second, let me share a few words about Greenlight Guru and why we put on these free training sessions. If you've been on one of our training sessions before, then you know that we put these on because improving the quality of life is our mission at Greenlight Guru. This is likely a mission that's similar to many of you participating in today's webinar. Anything that we can do as an organization that helps device makers bring safer, life-changing devices to market quicker with less risk aligns with that mission. We're constantly looking for ways to fulfill that mission, whether that's through hosting these free training sessions, through partnering with world-class consultants like Mike Drews, or through our award-winning quality management software platform. If you'd like to learn more about why medical device companies all over the globe in more than 600 cities from over 50 countries are ditching their broken paper-based quality systems and outdated legacy software for a new modern quality management software platform designed exclusively from the ground up by medical device professionals specifically for the medical device industry, then I would encourage you to go to www.greenlight.guru after today's presentation and request your free personalized one-on-one demo. In it, you'll learn how the very best medical device companies are leveraging the Greenlight Guru EQMS software to gain ISO 13485 2016 certification, breeze through audits, and push beyond just compliance and embracing true quality. So like I said, if you're interested in learning how we might be able to help your device company, be sure to go to www.greenlight.guru after today's session and schedule your personalized demo. All right, so let's get on to today's presentation, and let me give a proper introduction to today's presenter, Mike Drews. Mike Drews is a regulatory strategy consultant specializing in designing novel regulatory strategies to bring new and innovative medical products to market and in developing effective communication strategies between companies and regulatory agencies to minimize time to market and avoid delays. Dr. Drews received his bachelor's, master's, and PhD degrees in biomedical engineering from Iowa State University. He works with leading medical device, pharmaceutical, and biotechnology companies ranging in size from early stage startups to Fortune 100 companies. He also works on a regular basis for the US FDA, Health Canada, the U.S. and European patent offices, the Center for Medicare and Medicaid Services, and other regulatory and government agencies around the world. Mike is an internationally recognized expert and featured keynote speaker on cutting-edge medical technologies and regulatory affairs. He conducts seminars and short courses for medical device, pharmaceutical, and biotechnology companies, the FDA, Health Canada, patent offices, CMS, and other regulatory agencies around the world. Finally, Dr. Drews is an adjunct professor of regulatory affairs, medicine, and biomedical engineering at several universities and medical schools. He regularly teaches graduate courses in regulatory affairs and clinical trials, clinical trial design, medical device, regulatory affairs, and product development, combination products, and pathophysiology. Physiology, that was a mouthful. Without further ado, let me hand it over to your presenter and proud to say good friend of mine, Mike Drews.
Well, thank you, John, for that very kind and somewhat long introduction. I want to thank you and all of my friends at Greenlight.guru for the opportunity to host this webinar today. And obviously a special thanks to the more than 1,000 people who we have signed up watching this webinar today, and countless more I'm sure will be watching after the fact. There is a handout that will be available for this webinar, and you'll be sent via email the details on how to get it. If you don't receive that, feel free to contact me. I'd be happy to send you that handout. So obviously the topic for this webinar today is the 510K, and one of the most important aspects of the 510K, substantial equivalence, subtitled Why Do So Many People Get It Wrong? This is a topic that I'm intimately familiar with, and I look forward to sharing some of my experiences with you. John just shared a lot of my bio that will also be in the handout as well, so I'm not going to go through that again. The only thing that I do want to mention is I'm a contributing editor to several very large medical technology and regulatory publications in the world. On the screen now, you see some of them that are being listed. I would encourage you to check out whatever topics that might be of interest, and I'll refer you to some of them through this particular webinar today. So for today, what I'd like to cover in the short time that we have is to try to provide a better understanding of what the regulatory requirements are for substantial equivalence, and as John mentioned a moment ago, how to use them to our advantage, to learn how to design a successful substantial equivalence strategy using regulatory logic, not just simply a regulation, but the logic, and most importantly, how to defend it. For those of you that have heard some of my podcasts, you perhaps have heard the metaphor that I use to describe the FDA. When FDA is doing their job, and let's be honest, they don't always do their job, but when they do their job is to be critical of everything. So if we walked into the FDA and said the sky is blue, FDA's job is to say, okay, prove it. If we walk into the FDA and say our device is substantially equivalent, it's FDA's job is to say, okay, prove it. Substantial equivalence should not be assumed. As a matter of fact, it should be not assumed. We should assume that our device is not substantially equivalent unless and until we prove that it is substantially equivalent. So that's one little piece of advice that I'll share with you as we get started in this webinar. In addition, I want to get into some much more sophisticated examples of regulatory strategies. For example, the split and the multiple predicate strategies and how to use each. And before any of my industry or FDA friends who are watching this start to get upset, the split predicate strategy is still an applicable strategy, even though FDA is in some cases no longer keen on it. But again, we'll talk about that more later. And you should be aware, obviously, of the new guidance documents and how to use them to your advantage. But my intention here is not to just go through guidance, because after all, you in this audience are smart people. You know how to read. You've graduated from elementary school. You don't need me to read the guidance to you. So I want to focus our time that we have on strategy as opposed to just reading the regulation or the guidance. What can we do if FDA says that our device is not substantially equivalent, or NSE? Does not substantially equivalent mean not substantially equivalent? The short answer is absolutely not, at least not necessarily, and we'll talk about what our options are in those kinds of situations. And finally, throughout the webinar, but especially at the end, I'm going to share with you some of the proposed changes that people are talking about literally in the last few days and weeks. But many of these changes are in fact not new, and some of them have been proposed and talked about for decades. But bottom line, knowing what the regulation says, although that's a good start, that's not enough. We need to go beyond simply what the regulation says. So just to kind of start out, I'd like to get a sense of where as an audience we are. I have a couple of questions that I'd like you to respond to. So John, maybe we can put these up so people can answer them. The first question is, have you previously worked on a 510K device in the past? The second, that's a yes or no question. The second, do you currently work on a 510K device now? Yes or no. Do you anticipate working on a 510K device in the future? Yes or no. And finally, the last question is a multiple guess. What % of 510Ks are successful on the first try? In other words, successfully go through the FDA without getting any questions or rejections. 75%, 50%, or 25%. So John, can we just take a moment and have the audience respond to those questions, please?
Absolutely. So folks, the first poll question is launched. So take a moment. All right. Mike, the results are, we'll just put them up on the screen. So there's the results for the first one. 74% yes, 26% no. All right, the
Okay.
next question is available now. So folks, take a moment to answer this. Okay, let's share the results there. Similar, 73% yes, 27% no on that one. Third question is on screen now. All right, probably not a big surprise. It's the topic we're covering today. 88% say yes, 2% no, 10% maybe. And then the last question is on screen now. All right, and the results for the last question, 10% say it's 75%, 28% of respondents say it's 50%, 62% of respondents say it's 25%.
Okay, terrific. Thank you, John, for helping to conduct that poll, and thank you to everybody in the audience. It helps me as a facilitator to kind of gauge the level of content here. So, bottom line, roughly 70 to 80% of the folks in the audience either have currently or anticipate working on a 510K, and about 2/3 of the folks in the audience got the correct answer to the last question. I'll share with you some statistics in a moment, but only about 25% of 510Ks are successful on the first try. And one of the most common reasons why they're not successful is because of the topic of today's webinar, and that is substantial equivalence, or the lack thereof. So before getting into substantial equivalence, let's just take a half a step back and talk a little bit about when a 510K is required. Now, again, my emphasis here is not to read the regulation to you, but rather to understand the regulatory logic. So there's two criteria that we use when we decide whether or not a 510K is applicable. First is in terms of risk. Basically, for a 510K, the device needs to be less than class 3 and greater than what I call class 0. Now, FDA does not use the phrase class 0, but I do. This would be equivalent to an unregulated medical device, like, for example, a wellness device. But basically, 510Ks are applicable to most class 2 devices and class 1 devices, assuming that we're not talking about an exempt device. Some of you have probably heard the phrase 510K exempt. It's a very confusing phrase to a lot of people in this industry. The word exempt means that you are exempt from an FDA filing like a 510K or a de novo. It does not mean that you're exempt from regulation. You still have to be FDA registered. You still have to have a quality management system and design controls and so on. It just simply means that you do not have to have a 510K or a de novo. The second criteria for a 510K is when we can show our device to be substantially equivalent to a predicate. So that's going to be the focus of today's discussion, more so on substantial equivalence than risk. But obviously, these two topics go hand in hand. As some of you may know, I happen to be a subject matter expert for FDA in several different areas, one of them being risk, and I'll talk more about that in a second. But although the topic of today's webinar is 510K and specifically substantial equivalence, don't forget about the de novo. There are many examples of medical devices that I've been involved with over the years that could have easily been brought to the FDA as a 510K, but we did not. Instead, we brought it to the FDA as a de novo for a number of reasons, not the least of which is the competitive reasons. So bottom line, we're focusing on 510K and substantial equivalence here, but don't forget about the de novo. One of the advantages of the de novo, of course, is you don't have to worry about substantial equivalence. There is no substantial equivalence in the de novo. The next question I want to talk a little bit about is why substantial equivalence is important, or put another way, how well are we as an industry doing? Well, let me share with you some perhaps humbling statistics. What percent of submissions are kicked back on first review? For 510Ks, the statistics are pretty unimpressive, in my opinion, and that is about 2/3 to 3/4 of 510Ks are rejected first time out of the box. And for those that are working in the PMA world, it's even higher than that. And for the 510Ks that are rejected, 85% of them are rejected specifically because of substantial equivalence or the lack thereof. As I've said publicly many, many times, a 510K should never be rejected because of substantial equivalence. That is a very amateur mistake. I see sometimes some of the largest medical device companies on earth get their 510K rejected because of substantial equivalence. And I don't mean to be harsh here, but all I have to do is basically laugh, because that's such an easy situation to mitigate. It just should never happen. And part of the reason why that this happens is because, as an industry, many people tend to treat the FDA as their elementary school teacher. In other words, here's my homework assignment. Will you please mark it up and give it back to me? And I'm sorry, but that is not the way this game is supposed to be played. So should we be proud of these statistics? Well, I'll leave that as a bit of a rhetorical question. Oftentimes I hear my regulatory friends, they say their goal is to get their 510K cleared, or their de novo granted, or their PMA approved. That has never been my goal, because quite frankly, any monkey can do that. My goal is to get my 510K cleared, ideally first time out of the box if I can. If I can't, with a minimum number of questions or kickbacks going back and forth. Am I successful 100% of the time? Absolutely not. But I can say that I'm in the 20 to 25%, not the 70 to 75%, and that's something that I am very proud of. As a matter of fact, I set the bar very high. I view any submission that comes back to me with questions is a failure, flat out 100% failure. I work really hard to get all of the questions answered in advance, so that once the submission goes in, really, assuming all the data shows what we say it's going to show, it's just a matter of collecting the signatures and working its way through the system, and we're done. Unfortunately, that doesn't happen very often in this industry today, but it can. And so that's something that we should aim for. I've done a lot of webinars and podcasts on the pre-submission process. One of my favorite ways to accomplish the level of success that I have is by taking our device to the FDA long in advance of the submission, in the form of a pre-submission meeting or a pre-sub, to try to make sure that we're in the 20 to 25%, not in the 70 to 75%. Something to think about. So most 510Ks are determined to be substantially equivalent eventually, but please notice I added the word eventually. That's not good enough, at least not for me. I want my device to be substantially equivalent, determined to be substantially equivalent right away, not after back and forth of Q&As and so on and so on. As I said before, and I mean this sincerely, no 510K should ever be deemed to be not substantially equivalent. It's just a very amateur mistake. Next question is, what are the two most important components of a successful 510K? Simply put, they are substantial equivalence and risk mitigation. Bottom line, unless you have a very strong substantial equivalence argument and a bulletproof risk mitigation strategy, your 510K is simply not going to be successful, at least not first time out of the box. I don't care if you fill out all the forms properly. I don't care if you dot all your I's and you cross all your T's. If you don't have a strong substantial equivalence argument and a bulletproof risk mitigation strategy, you are not going to be successful. I'll give you a quick example. Many medical devices have come onto the market in the past here in the United States under the 510K, say 10 years ago or even 5 years ago. If the same device came to the FDA today with exactly the same submission, it might not get through. And the question is why? What has changed? Has the regulation changed? No, absolutely not. The regulation for the 510K has not changed since it was created in 1976. But what has changed is the level of, shall we say, scrutiny that FDA is applying to certain parts of the submission. And the two most important parts are the substantial equivalence argument, which is what we're talking about today, as well as the risk mitigation strategy. Okay, so talking about substantial equivalence and risk, is there a governing equation for the 510K? Now, I come from an engineering background. I like to think in a logical fashion, which is not something that I can say for all of my regulatory friends. But here is my governing equation for the 510K, starting out with the two fundamental equations. As I said a moment ago, a successful 510K includes both substantial equivalence as well as risk. On the substantial equivalence side, there's two components of substantial equivalence. One is labeling and the other is technology. So if we take equation number 2 and sub it into equation number 1, we get the what I call the governing equation of the 510K. And that is a successful 510K must address substantial equivalence, both components, labeling and technology, as well as risk. Now, risk is the topic of a completely different discussion. I've done some webinars, including for Greenlight on risk. I'll give you the reference to that in the handout. But what we're focusing on here is the labeling and on the technology. And by the way, when I design 510K submissions, I decouple labeling and technology. In other words, I do not, as many do, combine labeling and technology at once. I talk about why my labeling is substantially equivalent to my predicate, and then I also talk about why my technology is also substantially equivalent to the predicate. Many people don't decouple them. Many people we'll talk about them together. I'm not saying that that's wrong. What I am saying is that it is more complicated, it is potentially more confusing that way, and therefore it's more likely that there's going to be questions and problems. So by decoupling these two and addressing them separately, I think we simplify that, and one of our goals here is to simplify the information as possibly can, as much as we possibly can. Bottom line, any successful 510K has to solve the above equation. We have to have a valid and defensible solution for that equation, the 510K governing equation. If there's no valid solution, or if it's an indefensible solution, then we need to consider another pathway to market. If it's still less than class 3, we might consider the de novo. If it's not less than class 3, then in other words, if it is class 3, then the PMA or the HDE or something else. Bottom line, don't focus on what the regulation says. Yeah, that's important, but focus instead on understanding the regulatory logic. In other words, the thinking process, which, at least in my opinion, in more than 25 years of playing this game, is infinitely more important than the regulation itself. I mentioned the risk webinar that I did for Greenlight just last year. I've developed my own, what I call my 3-bucket approach to risk, which I think is a more comprehensive approach to risk as opposed to the ISO and the other forms of risk. And FDA has adopted a version of my 3-bucket approach to what they accept as well. So for those that are interested in risk, I would point you to this particular webinar, and I have other resources. Send me an email. I'll be happy to provide those to you. So let's dig in more detail and more deeply here into specifically substantial equivalence and what the heck does it really mean? Well, one of the first things we could do is we could read the regulation, we could read the guidance, and that's a good first step, but we need to dig deeper. So let's take a look at what the regulation for substantial equivalence means. And by the way, what I'm showing you here, this comes from the CFR. This is not guidance. And this CFR regulation has not changed at all since the 510K was created in 1976. So what the regulation says, substantial equivalence means that a new device is at least as safe and effective as a predicate. And substantial equivalence means that we have the same intended use and the same technological characteristics as the predicate. Okay, that makes sense. Or the same intended use in different technological characteristics. What the heck does that mean? I have no idea. And again, I hope everybody appreciates my not-so-subtle use of humor here, because this is exactly what the regulation has said since 1976. the same intended use and the same technological characteristics, or the same intended use in different technological characteristics. And if it does have different technological characteristics, these differences in technology cannot raise additional questions of safety and efficacy, of risk, and so on and so on. In other words, it has to be at least as safe and effective as the predicate device. A claim of substantial equivalence does not mean that the new and the predicate devices are identical, and that's an important point. And now this comes to one of the most fundamental questions that the medical device industry has been struggling with since the 510K was created in 1976, and that is, how different can two technologies or two different devices be, and yet still be similar enough, close enough to be substantially equivalent? Yes, FDA has put out a number of guidances over the last 40 plus years. I'll share with you a couple of them as we continue. But bottom line, there is absolutely no answer to that question. It's incumbent on us to go to the FDA and say, our device is substantially equivalent to the predicate, and here are all the reasons why, or our device is not, and here are all the reasons why. So the solution to this problem, in my opinion, is not with more regulation or guidance, but with understanding the intent. Bottom line, this is very easy to understand in theory. It's very easy for anybody to put these words up in a PowerPoint slide, but what the heck does it really mean? So let's dig a little bit deeper into substantial equivalence. Another question that I get from people all the time is, in the 510K world, when do I need clinical data? When do I need to do a clinical trial for a 510K? As most in the audience probably know, most 510K devices do not require clinical data, but some do. And actually, the number of 510Ks that are requiring clinical data is rapidly increasing. So when is clinical data required? The regulation provides no answer to that question. And in my opinion, the regulation should not provide an answer to that question. It should be based on the technology, it should be based on the pathophysiology, it should be based on the risk, and so on. So clinical data is never required in a 510K. Similarly, and this might sound a bit odd to some of you, clinical data is also never required in a PMA. The short answer to every question in regulatory affairs is it depends. But specifically when it comes to the 510K, let's talk about the regulation. So there's two possibilities here. We have the same intended use and the same technological characteristics. That basically means we have a low regulatory burden and we will be less reliant on clinical data because our device is so similar to a device already on the market. On the other hand, if we have the same intended use and different technological characteristics, now we are going to have a higher regulatory burden, and we are going to probably need some or maybe a fair amount of clinical data. Bottom line, to make this as simple as I can, the more similar your device is to the predicate, both in terms of labeling, but especially technology, the more likely you won't need much, if any, clinical data. On the other hand, the more different your device is to the predicate, the more likely you're going to need clinical data. And the greater the difference, the greater the amount of clinical data. The FDA considers what my attorney friends like to call the totality of the evidence. The totality of the evidence. So when we add up the evidence from your benchtop testing, from your animal testing, from your clinical testing, and so on, is the totality of that evidence sufficient to show that your product is safe and effective? Simply put, the more similar your product is to the predicate, the more reliant you can be on data from the predicate as well as from benchtop testing. But as you get more and more different from the predicate, then you're going to have to probably have clinical data. So the more similar you are, the less you have to do. But is this a good thing? You know, oftentimes when companies come to me and they say they want to get their device onto the market as quickly and simply and cheaply as possible, I say to them, okay, if you want to do that, then I have one piece of advice. Design your device, both in terms of labeling and technology, to be as close as you possibly can to your predicate. That's the simple advice from a regulatory perspective. Now, from an engineering perspective, it makes me cringe when I give that advice because it's encouraging companies to bring out products that we already have. In academia, we call it plagiarism. But from a regulatory perspective, regrettably, that is the incentive. That is exactly what we want to do. So how do we demonstrate substantial equivalence? at least in the submission sense of the word. And I have several examples that I'm going to share in just a moment. Well, here's a flow chart from one of the FDA guidances. I don't have time in this webinar to go through all of the different steps. It really doesn't matter much. Most of them are pretty obvious. But we have to dig deeper, because if it was simply a matter of following this flow chart, how can we explain those pretty unimpressive statistics that I shared with you? In other words, how do we connect these dots? So many of my friends at FDA, their advice to companies is just follow the flow chart. But that's, not enough. You have to understand what this means. So digging into this some more, the different decisions in the flow chart are: is the predicate a legally marketed device? We respond to that question. That's a pretty easy one. The second decision: do the devices have the same intended use? So in this particular case, we're talking about a labeling comparison. So what I do is I present a labeling matrix. I put my labeling for my new device right next to the labeling for my predicate, and I do a word-for-word comparison. And as a matter of fact, what I like to do, and I talk about this in my labeling webinar, is for the words that are the same, I highlight those in green. For the words that are a little bit different, I highlight those in yellow. And finally, for the words that are very different, I highlight those in red. What I'm trying to do, kind of like a traffic light, red, yellow, green. What I try to do is I try to highlight the similarities and the differences. So simply put, the more green that I have in the two labels, the more likely I'm going to be successful with a 510K. The more red that I have in the two labeling statements, the more successful I would be with the de novo. So do the devices have the same intended use? That's the labeling comparison. Decision 3, do the devices have the same technological characteristics? Now, again, with all due respect to my many FDA friends, I have never seen two medical devices that have exactly the same technological characteristics. It just does not exist. There's always going to be at least some minor differences. So once again, I take the exact same approach. I create a technology matrix, and for the technologies that are the same, I highlight those in green. For the technological characteristics that are different, I highlight those in red, and for the ones that are in between, I highlight those in yellow. So the regulatory logic on both the labeling as well as on the technology side is exactly the same. Of those technological differences that do exist compared to the predicate, do they raise additional questions of safety and effectiveness? And once again, we have to respond to that. Just because they do does not necessarily kick you out of the 510K, but you do have to address them. Then finally, we get to decision 5, which is into two parts. Are the proposed scientific methods for evaluating new or different characteristics of safety and effectiveness acceptable? It's an interesting kind of a phrase to that question. Acceptable to whom? I guess in this particular case, acceptable to FDA, but remember, it's our job to convince them of what's acceptable. And finally, does the performance data demonstrate substantial equivalence? And this is where we do oftentimes a benchtop head-to-head comparison. We do a test on our device and the same test on the predicate device, and we compare the data head-to-head, so to speak. We have to address all of these questions in order to get through the flow chart. Now, bottom line, and for those of you that have heard some of my podcasts in the past, I'm not a big fan of flowcharts for lots of reasons, not the least of which is I can manipulate the results of the flowchart to be anything that I want. In other words, if I want to bring this device onto the market as a 510K, I will manipulate the flowchart to pass all of those questions. On the other hand, if I want to bring this device onto the market as a de novo, I'm going to manipulate the flowchart in order to fail one or more of these questions. So the FDA, simply put, they like it when you use their flowcharts. I don't, but to play the game, I'll use the flowchart. More importantly, has anything changed since in the 40 plus years? This is a version of the flowchart that was published in the guidance in 2014. This same flowchart, the same logic, has been in existence since 1976, as we've been talking about, and this was just updated last month. I'll show it to you in just a second. So another question that I hinted at a moment ago: what does different technological characteristics really mean? Or put another way, how different can two medical devices be and yet still be similar enough, close enough to be substantially equivalent. Remember, we have to address all three of these things: labeling and technology, which is part of the substantial equivalence argument, but also risk. There is absolutely no simple answer to this question. But just because there's no simple answer shouldn't scare anybody. It just means that there's no simple answer, and we have to do our homework, and we have to be able to defend it at the FDA. So this is from that 2004 guidance, showing exactly the same verbiage that we went through a moment ago. Easy to understand, but difficult in reality. And just last month, a couple of months ago now, FDA updated that particular guidance. But the question is there really anything new here? And they did a webinar last month talking about this guidance. But I find it ironic. The 510K was created in 1976, more than 4 decades ago, and yet industry and FDA today are still trying to figure out what the heck substantial equivalence really means. In other words, if substantial equivalence was so simple, why are there so many NSE determinations, and is more guidance or regulation the solution? In my opinion, absolutely not. Einstein, very smart guy, said if you can't explain something simply, you don't understand it well enough. Regulation is all about the interpretation of words and our ability to defend our interpretation. This is a very important point. Regulation is all about the interpretation of words and our ability to defend our interpretation. We can interpret words in many different ways. And by the way, the words for the 510K in substantial equivalence has not changed one word, one punctuation mark since it was created in 1976. But what has changed is interpretations. And speaking of interpretations, why would anybody assume that FDA's interpretation is any better or any more valid or any more correct than yours or mine or anyone else's, right? They don't have any secrets here that nobody else knows about. So it's our job to go into the FDA and say, here's what the regulation says, and here is how it applies in our particular situation. And this is going off on a tiny bit of a tangent, but as most of you know, there are different kinds of 510Ks. The special 510K is another option. Is substantial equivalence important in the special 510K? Well, from a regulatory theory perspective, absolutely not. Or is it? Well, a special 510K, as many of your audience knows, is typically used when we make a change to an existing medical device. So there is no real necessity to talk about substantial equivalence in a special 510K, but if you understand the regulatory logic, the logic is exactly the same. The question that you should be asking, and this is a topic for a different discussion, but the question that you should ask is the changed version of our medical device substantially equivalent to the original version of our medical device? Now, there is no explicit regulatory requirement to show that in a special 510K. It's sort of implied in the special 510K, but that's the regulatory question that we should be asking. Is the changed version of our device substantially equivalent to the current version? All right, so how do we show substantial equivalence? Well, we can do it in a lot of different ways. The regulation says we have to show our device is substantially equivalent, but the regulation does not say how we should show it. And in my opinion, the regulation should not tell us how to show it. That should be 100% up to us. So there's a couple of different methods that we can do this. The first method is to do a direct, or what I call a head-to-head comparison. This is by far the most common way that companies in the past have done it, although this could be changing with the so-called alternative 510K that Scott Gottlieb was talking about the end of last year. I mentioned this a moment ago. This is when we take our device and subject it to some testing, and we take the predicate device and subject it to exactly the same testing, and then we compare the results. So this is the most common, this is the most controlled, this is the easiest to sell, and based on the new changes going into effect in the EU, this is what they're encouraging now in the EU to do, this head-to-head comparison. An alternative way to show substantial equivalence is to do what's called an indirect, or what I call a paper comparison. And this is now exactly what Scott Gottlieb is encouraging companies to do. It's the crux of the alternative 510K. And by the way, as John and I have talked about in some of our previous podcasts, it's really not an alternative 510K. There's nothing at all new here. This is just simply a reincarnation, if you will, of the abbreviated 510K that's been around for a very long time. And a paper comparison, basically what we do is we compare on paper our results to what we find for our predicate from the literature or from subject matter experts or some other way. In other words, we don't collect the data ourselves. And this is an opportunity to get quite creative. I've been involved in several medical devices where the predicate is no longer commercially available, but there is still an active 510K. So we could not do a head-to-head comparison even if we wanted to, because we cannot physically get the device. And yet we still can bring it onto the market as a 510K if we do it in this indirect or this paper comparison way. Bottom line, the regulation says that we're required to show substantial equivalence. How we show it is totally up to us. And please don't wait until you actually make your submission to show the FDA how you plan to establish substantial equivalence. You really need to consider taking this to the FDA in advance of your submission in the form of a pre-submission meeting or some other way that you want to communicate with the agency. I don't really care how you do it as long as you do it, so that everybody agrees in advance that this is the appropriate way, the appropriate method to show substantial equivalence, because otherwise you can just about guarantee that you're going to be in that 70 to 75% that are rejected, not in the 20 to 25% that are not. Okay, so let's take a look now at some examples of substantial equivalence strategies. And remember, the regulatory logic here is key. I'm going to start out with some very, very simple metaphors because, again, as I said earlier, Einstein, very smart guy, said if you can't explain something simply, you can't understand it well enough. So is a car substantially equivalent to a truck? If we went to the FDA and we were trying to argue that a car is substantially equivalent to a truck, how would we do it? What would the regulatory logic be? Well, step one in the substantial equivalence logic is stress the similarities. So both are vehicles that travel on roads, both have engines, both have tires, both burn some sort of fuel or energy, both transport people. So what am I doing? I'm stressing the similarities. That's step one. I'm stressing the similarities. Step two is I'm going to de-emphasize or not draw attention to the differences. So in other words, yes, both are vehicles that travel on roads, but usually trucks are larger than cars. Usually trucks have, maybe as many as 18 wheels. Cars will only have 4 wheels. Usually trucks might burn diesel fuel. Cars will burn gasoline or perhaps electricity if it's a hybrid. So I need to acknowledge the differences, and at the same time, I need to mitigate those differences. So why are those differences not important? In other words, yes, a truck has more than 4 wheels, but it's not a problem, and here are the reasons why. Yes, a truck burns diesel fuel and a car burns gasoline, but at the end of the day, both get down the road equally as effectively. So I need to be able to dismiss those differences, and I also need to address any new risks that those differences might introduce. Also, the regulation says we have to have a predicate. The regulation does not say how close or how far the predicate needs to be. So I can compare a car to an 18-wheeler truck, or I can compare a car to a pickup truck. There are advantages and disadvantages to both. The regulation does not say how close or how far that they need to be. Now, everything else being equal, I would probably choose a pickup to compare to a car because it's a closer comparison than to an 18-wheeler, but I do not have to do that. And if I were to choose the 18-wheeler, the first thing I would do when I go into the FDA, I would say, I'm bringing my car onto the market. I'm going to compare it to an 18-wheeler truck. But before I talk about why I'm comparing it to an 18-wheeler, let me tell you why I'm not comparing it to a pickup truck. This is a basic strategy that I use at FDA all the time, and that is I want to take away every possible reason that I can that FDA can disagree with me. In other words, I want to demonstrate to my FDA friends that I know all of my different options, and quite frankly, I know what the heck that I'm doing. And by the way, the regulation also doesn't say how recent the predicate needs to be. In other words, 1 year, 5 years, 10 years ago, 40 years ago. This is one of the changes that's being discussed now. Some people have suggested that we should limit predicate selection to comparing our device to a device that was brought onto the market just in the last 10 years. I'm adamantly against that because that's going to hamstring my ability to use the best predicates that I can. Just because a predicate was brought onto the market does more than 10 years ago doesn't mean that I shouldn't be able to use it. But on the other hand, just like I did with the trucks, if I go to the FDA and say I'm going to use a predicate from 25 years ago, before I talk about why I'm using that predicate, let me tell you why I'm not using a more recent predicate. That job is on us. In other words, we have to justify not just what we do, but what we don't do as well. So where do we draw the line and who decides? That's a totally different conversation. So my ongoing challenge is to try to simplify things so that people can understand them, while at the same time not oversimplifying to the point of introducing error. Or as Einstein said, if you can't explain something simply, you don't understand it well enough. So let's go into some more detailed examples of substantial equivalence and what does it really mean. Is a blue car substantially equivalent to a red car? So once again, I'm getting closer in that predicate continuum, as I like to call it. The question that you have to ask yourself is, if it's a darker blue, it might be more difficult to see at night than a red car, and therefore it might be higher risk. That might be enough to kick us out of the 510K. If you want to stay in the 510K, you need to mitigate that risk. You need to reduce that risk by, for example, maybe there's something that you can do to increase visibility. Maybe there's something that you can do to increase the lighting design and still keep it, minimize the risk, keep it substantially equivalent, and keep it still in the 510K universe. Is a longer car substantially equivalent to a shorter car? Once again, there's no answer to these questions. It's up to us to be able to argue and defend them. So what if the added length decreased the maneuverability, for example? That would create a higher risk, and as a result, that might kick us out of the 510K universe. So how can we mitigate that risk? Well, perhaps we can add four-wheel steering, or perhaps a backup camera. Or some other technological bell or whistle to mitigate risk, to keep it substantially equivalent and keep it in the 510K world. Is an electrically powered car substantially equivalent to a gasoline-powered car? Once again, there's no regulatory answer to that question. It's up to us to be able to argue that those differences don't matter. So what if the electrical powered car means we have a higher efficiency and lower emissions? Those are advantages. Does that mean that it's substantially equivalent? Well, we could make that argument and keep it in the 510K world. What if we have a car that can travel on water as well as on ground? Or for that matter, a car that can fly through the air compared to a car on ground? What we're doing is we're pushing further and further in that technological continuum. How similar, or alternatively, how different can two devices be? Here we're talking about in a technological way, and yet still be close enough to be substantial equivalence. You can read the regulation, you can read the guidance, including the guidance that just came out last month. From now until the sun burns out, it is not going to give you an answer to these questions. The technology has changed, but has it changed enough? In other words, is it still substantially equivalent? Is it still 510Kable? And we've been talking about technology here. Don't forget the labeling side. Has the labeling changed enough to make it not substantially equivalent and to kick it out of the 510K? You have to include labeling and technology as part of your substantial equivalence argument, and you have to also remember risk as well. These are both independent but also interdependent. I treat them, as I said earlier, I treat them separately first, But then I add them all together and I treat them collectively. And that's another reason why I'm in the 20 to 25%, not in the 70 to 75%. Let's use another simple metaphor to illustrate substantial equivalence. Is an apple substantially equivalent to an orange, as this cartoon illustrates? That question is completely unfair. It's like comparing us to them. But seriously, if we went into the FDA, and by the way, what does F in FDA stand for? It stands for food. So here we're talking about a food example. Is an apple substantially equivalent to an orange? Well, the logic I'm going to use is exactly the same as the logic I use for cars and trucks. I'm first, for step one, stress the similarities. So both are fruits, both grow on trees, both have skins, both have seeds, both deliver nutrients, calories, vitamins, and so on and so on. So I emphasize all of the similarities. Step two in the substantial equivalence logic is to de-emphasize or not draw attention to the differences. Yes, they're both fruits, but they're different fruits. They both grow on trees, but they're different trees. They both have skins, but in the case of the apple, most people eat the apple skin. In the case of the orange, most people don't. So once again, I have to address all of those differences, and to the extent that I can, I have to mitigate those differences to show that they're not important, that they don't impact safety and efficacy, that they don't add additional questions of risk, and so on. Bottom line, the stronger that you can make that substantial equivalence argument, the more likely you are going to be successful with your 510K. Alternatively, the weaker your substantial equivalence argument is, now you need to consider a different approach, perhaps the de novo. Let's take this a step further. Still using apples to explain substantial equivalence. Is a red apple substantially equivalent to a green apple? So once again, I hope everybody appreciates my not so subtle use of humor here. I'm getting closer and closer in the predicate continuum. So, in the technology continuum. So both are fruits, both grow on trees, both have skins. There's a lot of similarities here, but there's one glaring difference, and that is color. Now, for those of you that know something about biology, all kinds of bells and whistles should be going off in your mind if there's a observable difference, a color difference between these two apples, what we call a phenotypical difference. What also must there be in these two apples? A genotypical difference. Enter substantial equivalence when it comes to A's, T's, G's, and C's as we face in molecular biology, for example, in molecular diagnostics, a part of in vitro diagnostics. This is well beyond the scope of this particular webinar, but what the heck does substantial equivalence even mean when it comes to sequences of A's, T's, G's, and C's? That's a topic for a whole different discussion, and I do spend a fair amount of my time developing regulatory strategies, including the 510K for in vitro diagnostics. It's an interesting world. And similarly, how about a dark apple? Is it substantially equivalent to a light red apple? So once again, I'm getting closer and closer in that technology comparison. And what happens if we combine them? You can appreciate my not so subtle use of humor here. If we push, pardon me, if we push the technological envelope even further, how about a non-browning apple? We have now the technology to grow non-browning apples. Is that substantially equivalent to a conventional apple? This is a technological difference. The regulatory logic would be exactly the same. We have to address the similarities, and we have to de-emphasize or not draw attention to the differences. This is a spin on how different can two technologies be and yet still be similar enough to be substantially equivalent. And we also have to remember about the risk. In other words, for these technological differences, what changes in risk to go down the risk rabbit hole just very, very quickly. When it comes to the 510K, the risk requirements are quite simple. There are only two. The first requirement is that there can be no new risks in the subject device compared to the predicate. And the second requirement is that of the known risks in the subject device have to be the same level or lower than compared to the predicate. That is what the regulation has said with regard to risk in the 510K since 1976. However, as I'll talk a little bit about at the end of the webinar, that regulation has never been interpreted as literally as I just said. But now, most recently, I see some changes, possibly at FDA, that are taking a more literal interpretation to risk. And if we have time, we can talk about that a little bit at the end. Anyway, And in this era of combination products, what happens when we start to combine these things? That's a topic for a much more advanced discussion. This is from an article from Scientific American a couple of years ago. If two images are similar, the brain assumes that they're identical. Well, for my medical device friends in the audience, if two medical devices are similar, should we assume that they're substantially equivalent? In my opinion, no. We should assume that they're not substantially equivalent unless and until we prove that they are substantially equivalent. Bottom line, they're similar, but they're not the same. So how similar must they be to be substantially equivalent? Or alternatively, how different must they not be to be substantially equivalent? Once again, that's up to us to draw the line and then to take it to the FDA and sell it to them. The next example is using ketchup and mustard to explain substantial equivalence. Is ketchup substantially equivalent to mustard? Now, you've been listening to me for a while in this webinar talk about substantial equivalence. You're probably getting a little tired of hearing me. Let me share with you a video from a friend of mine. Some of you might recognize this person in this video who talks about substantial equivalence. Watch this.
One word. The reason I want to talk to you a little bit today is I had a meeting with a friend recently who's newer to the medical device industry, and I was trying to explain the FDA process for getting device approval. As you might know, FDA has three classifications for medical devices: Class 1, Class 2, Class 3. Class 1, really simple products, things like tongue depressors. Class 3 are permanent, usually permanent implants or higher risk products. The majority of medical devices fit into the Class 2 category. And the way you get FDA clearance for those products is a submission called a 510K. 510K, what you need to do is demonstrate that your product is substantially equivalent to a product that's already on the market. How do you do that, you might say? Well, as I was explaining this to my friend, I used condiments. I said, let's imagine that you're mustard, and that you're a medical device, Class 2, and you're already on the market. And mustard goes great on hot dogs, sandwiches of all kinds. But here I am, I'm developing a new product, and my new product is called ketchup. So how do I get ketchup on the market? Ketchup is clearly much better than mustard. It's much more versatile. It can be used on French fries, hamburgers, in addition to hot dogs. And it's used as a base ingredient for a lot of sauces and so on and so forth. So clearly ketchup is better than mustard. But if I'm too novel, too unique, it's tough to get to the market through the FDA process through a 510K. So I have to.
Let me just pause. And by the way, for those in the audience that don't recognize who this person is, this is John Spear, who's co-moderating this webinar and co-founder of Greenlight Guru. So I give John 100% credit for this particular video. Obviously, it's an absolutely brilliant example of explaining substantial equivalence in a very simple, easy to understand way. Now, the first thing that I want to mention what John said in this video, and that is clearly ketchup is better than mustard. Well, from a regulatory perspective, we don't want to do that. When we go to the FDA, we absolutely do not want to say that our device is better than our predicate device. That would be the kiss of death. Instead, we want to say that it's basically the same, i.e. substantially equivalent. However, when your device gets on the market, your marketing people don't want to say that it's the same. They want to say that it's better. Well, how the heck can a medical device be the same and yet better at the same time? I have no idea, but this is exactly the dance that we've been playing for the last almost 45 years since the 510K was created. That's one of the biggest ironies of the medical device world. Let's move on to the last few seconds of this video, where John's going to do exactly what I did with the apples and the oranges and the other examples, and that is stress the similarities and de-emphasize or not draw attention to the differences. Here's the rest of the video.
Be able to show that ketchup is substantially equivalent to mustard. Well, they're both condiments. They're both in plastic containers, and they're both used on hamburgers, hot dogs, things of that nature. So I'm demonstrating that my ketchup is substantially equivalent to this mustard, this competitive product out there. But it gets a little tricky. If you want to advertise or market the additional benefits that ketchup might have, you need to make sure you have 510K clearance. So it's a little bit of a slippery slope sometimes, but remember, you need to compare your product to something that's already on the market and be able to show substantial equivalence. So that's a little bit about the 510K process.
Okay, so that's my friend John Spear's spin on the same thing, and I think we're both exactly on the same page. So in the last few minutes of this webinar, I'd really like to kick things up a few notches and talk about some much more sophisticated substantial equivalence strategies. And we're still going to be using these same simple metaphors like the ketchup and mustard to get into the split and the multiple predicate strategies. When used effectively, these are some of the most powerful regulatory strategies in the medical device universe. Unfortunately, when they're not used properly, they can cause a lot of problems, and we'll talk about that. So what's another way to get ketchup on the market if it was new? Well, this is an example of what's called the split predicate strategy. Now, please understand that the split predicate strategy and the multiple predicate strategy, which we'll talk about next, these are not the same things. Okay? Sometimes people use them synonymously, but they are not synonymous. So the first question is, what other products have similar individual functions? In other words, let's try to deconstruct the ketchup. So what do we find in the ketchup? In the ketchup, we have tomatoes. Those are on the market. Vinegar, that's on the market. Sugar, that's on the market. A variety of spices, those are on the market. We add all those things up together, and we get ketchup. This is the essence. This is the regulatory logic of the split predicate strategy. Now, in the interest of full disclosure, I was one of the very first people at FDA, probably about 25 odd years ago, to successfully use the split predicate strategy for, at the time, a multifunction monitor. Today, multifunction monitors are ubiquitous, but back in the day, there were no multifunction monitor. A multifunction monitor is nothing more than a blood pressure monitor, an EKG monitor, a respiratory rate monitor, and so on, all put together in the same box. So what we did is we took the multifunction monitor to the FDA and we deconstructed it. We said, in this, it's a blood pressure monitor. Okay, those have been around for a long time. A EKG monitor. Okay, those have been around for a long time, and so on. And we added them all together, and then we get our multifunction monitor. Right? So the logic of the split predicate strategy is exactly as simple as I just explained. This is a form of what I call indirect precedent because we're not using a predicate that is exactly the same. Instead, we're deconstructing it, as I just said. Now, regrettably, the split predicate strategy has become controversial because, how do I say this? There have been companies who have brought medical devices onto the market in the past using the split predicate strategy that, quite frankly, that never should have been allowed, and as a result have harmed people and in some cases even killed people. And as a result, some people, including some folks at FDA, have gone so far as to suggest that companies should not use the split predicate strategy anymore. I strongly disagree. The split predicate strategy is a very safe and effective tool when it is used properly, when it is used by people that, quite frankly, know what the heck they're doing. But unfortunately, just like any other tool, if it's used by people that don't know what the heck they're doing, then problems can happen. And so as a result, a few years ago, in one of the guidances from, I think, 2014, FDA said that companies should not use the split predicate strategy. Now, I find it interesting that CDRH said this in a guidance. Guidance is inherently not binding. Congress has not come out yet and said that they shouldn't use the split predicate strategy. I would be strongly against Congress saying that. And on a personal note, I have to be a little careful here. I have a number of FDA reviewer friends in CDRH who personally disagree with CDRH's policy of discouraging the split predicate strategy for the same reasons that I do, and that is it's an effective tool when it's used properly. When it's not used properly, it can cause a lot of harm. So the best advice I can give to companies today is if you're going to consider this using the split predicate strategy, first of all, only use it as a strategy of your last resort. In other words, try to use something else first. And if you can't use something else first, if you genuinely believe that the split predicate strategy is the appropriate strategy for you, then please, by all means, take it to the FDA in advance in the form of a pre-sub and say, here's our device, this is the way that it works. We're going to bring it onto the market as a 510K. We're going to use the split predicate strategy, and here are all of the reasons why. In other words, you want to be able to get the agency and the company to be on the same page at that point, because otherwise you're just wasting your time. You might as well, if you're going to use the split predicate strategy, and the first time that FDA sees this is in your actual submission, there's no better way to just about guarantee that you're going to have that submission thrown right back in your face if you don't take it to them in advance. You're not required to take it to them in advance. Obviously, pre-subs are optional, but I think in certain circumstances, like for example the split predicate, the pre-sub should really be mandatory. Remember, it's the thought process that's important here, and this is what regulatory science, if there is such a thing, should be all about. So that's a little bit about the split predicate strategy. Now let's talk about the multiple predicate strategy. So when we talked about the split predicate strategy, I asked you to use ketchup as a metaphor. When we think of the multiple predicate strategy, the way I like to think about this is a stool, where the seat of the stool is our new device, and each of the legs under the stool represents a single predicate. So if we have a stool with only one leg, obviously that's very unstable, that's going to fall down. If we add a second leg, it's more stable, but it's still going to fall down. If we add a third leg, it becomes more stable, and so on and so on. So the more legs under the stool, the more stable the stool becomes, the stronger the stool becomes. But it's not just the number of legs under the stool that's important. It's the relative strength or length of each one. So if we have a stool, for example, that has 7 legs, but one of the legs is much longer or shorter than the others, now the overall stability of the stool becomes compromised. Okay, so this is what I call fine-tuning our regulatory strategy. In other words, once we identify all of the different predicates, I'm going to weight each of those predicates. I'm going to kind of balance them, if you will, to make sure that I maximize the stability of my stool. Bottom line, if I can use this metaphor to make this as simple as it possibly can, you all as a company, you want to design your stool to be as stable as you possibly can make it. FDA's job is to do everything they possibly can to knock it down. At the end of the day, if your stool is still standing, you win. If the stool is not standing, you lose. It's as simple as that. Or is it? Both the split as well as the multiple predicate strategies are, in my opinion, safe and effective regulatory tools when they are used properly. But when they're not used properly, just like a scalpel in the hands of a skilled surgeon can be a very effective tool. A scalpel in the hands of somebody else, not so much, right? Something to think about. Taking this a tiny bit further, and then we're going to wrap this up for some questions at the end, talking about direct and indirect predicates or precedent. If we want to bring ketchup onto the market, we could use another form of ketchup if there is one, but must we? The short answer is no. We do not have to use another form of ketchup. We could use pimento sauce, we could use baked beans, we could use mustard, we can use a litany of different things. So once again, I'm going further in that technological continuum, but it's our job to justify not just what we're using, but more importantly, why we're using it. It's not important what you use. What's much more important is your ability to defend it. Thinking outside the box, or in this particular case, thinking outside the bottle. Taking this one last step further, we talked about cars and trucks. Let me push that metaphor a step further. Cars versus airplanes. Is a car substantially equivalent to an airplane? In other words, I can drive a car from Boston to Los Angeles. I can fly an airplane from Boston to Los Angeles. At the end of the day, either way, I end up in Los Angeles. Therefore, by regulatory logic, if there is such a thing, a car is substantially equivalent to an airplane because the intended use is the same. In other words, I end up in LA in both cases. The technology that I use to get there does not matter. That is exactly what the regulation says. But we can push this even further. Is a bicycle substantially equivalent to a car? I can ride a bike from Boston to LA. I can ride a motorcycle from Boston to LA. I can take a cruise ship down through the Panama Canal from Boston to LA. I can fly a helicopter. I can take the space shuttle. I can take a UFO if I want to. This is exactly why the 510K is the most controversial pathway to market, never mind just in the medical device world, but in the entire medical technology world as well. There's nothing even remotely controversial to the 510K in the drug or the biologic world. It's because of the slippery slope nature of the substantial equivalence logic. In other words, where we draw the line and who decides. Regrettably, some people have drawn the line in places that they probably should not have, and FDA has not pushed back as hard as they should have, and as a result, some medical devices, not many, but a few medical devices have been brought onto the market over the years that, quite frankly, should have never been brought onto the market under the 510K and have harmed people, and as a result, now is generating a lot of discussion in terms of how do we fix these problems. So very quickly, a little more on how do we present the similarities and differences. Now we're going to get into some much more sophisticated regulatory strategy, the difference between what I call the separation strategy versus the amalgamation or the fusion strategy. Most of the time when we talk about substantial equivalence, I use the separation strategy, which is what I've used in the simple examples before. We want to emphasize the similarities and de-emphasize or not draw attention to the differences. But in some cases, it doesn't make sense to do that. In roughly about 25% or maybe a third of medical device 510Ks, I use what I call the fusion strategy. And here's what I mean by that. I'm just going to go to the example on the table at the bottom of the screen. So imagine scenario number one. We have our device, a predicate, and the units there are whatever you want. Some technological parameter could be length, it could be weight, it could be strength, it could be temperature, it could be power, whatever you want. So the predicate is from 0 to 200. That's what they're labeled. Our device is also labeled 0 to 200. The regulatory logic there is very simple. It's 100% overlap, so there's really nothing that I have to do. My regulatory risk is very low. Now let's move on to scenario number two. Our predicate is still 0 to 200. Our device is labeled 100 to 200. So now we have an overlap. The 100 to 200 is an overlap, but we also have an omission. We're excluding the 0 to 100 range. In this particular case, it's ticking up our regulatory risk a little bit because we have an obligation. It's not a regulatory obligation, but in my opinion, it's an engineering obligation to provide a justification as to why we are excluding the 0 to 100 range. Remember, the regulation does not require us to do that, but I don't think the regulation needs to do that. To me, that's just basic engineering. So that's an overlap with an omission. Let's move down to scenario number three. Once again, the predicate is labeled 0 to 200, whatever. Our device is labeled 100 to 400, whatever. So now we have an overlap, an omission, and an extension. So now that kicks our regulatory risk up a little bit higher. So we have to justify why we're not using the 0 to 100 range. The 100 to 200 range, that's a no-brainer. That's an overlap. But now we have extended the range from 200 to 400. Please understand that the original predicate was probably never tested in the 200 to 400 range. And therefore, we have an obligation to provide the testing to demonstrate safety, efficacy, and so on for the 200 to 400 range. FDA is definitely going to expect that. And quite frankly, anybody that goes to the FDA and does not have the data to support that extension, that 200 to 400 range, if they don't do that prophylactically, then quite frankly, they're an idiot. They shouldn't be in this game because to me, that's common sense. And finally, the last scenario, number four, again, the predicate is 200 to 400. Our device is the predicate is 0 to 200. Our device is 200 to 400. Now we have a pure extension. Now our regulatory risk is much higher. And so now some of you might be asking, well, gee, why are you doing this as a 510K? Why don't you do it as a de novo? Well, remember, we're only looking at one technological parameter here. In the 25 years I've been doing this, I've never had a device where we only looked at one technological parameter to establish substantial equivalence. Usually it's a bunch, maybe 5, maybe 10, maybe 20, or even more. So imagine we have 10 technological parameters that we're looking at. Let's say 9 of them are overlaps, and 1 of them is an extension. In that particular case, it's probably still okay to do this as a 510K. On the other hand, if we have 10 technological parameters and 1 of them is an overlap, but 9 of them are extensions, now you might be better considering a de novo. Where it really gets interesting is if you're like in the middle somewhere, do you go 510K versus de novo? That's a more complicated discussion. And what if we use multiple predicates? The table that I illustrate here is for a single predicate, but if we're going to have multiple predicates with multiple technological parameters, this gets very complicated very quickly. This is, in my opinion, why FDA is trying to discourage companies from using multiple predicate strategies, because it is more complicated. And yes, it is more complicated, but just because something is more complicated doesn't mean that we shouldn't do it. So there's a lot of different possibilities here. Okay, so what happens when substantial equivalence goes wrong? Usually nothing good. Usually it leads to a long delay. Here's a quick example of a company that made a submission to the FDA for a 510K, and almost a year later, that submission was rejected because of substantial equivalence. Regrettably, this could have been totally avoided by going to the FDA in advance, but unfortunately, it doesn't always happen. Just 1 or 2 last things that I want to mention before we wrap this up. If FDA comes back and says that your device is not substantially equivalent, does that necessarily mean it's not substantially equivalent? Absolutely not. At least not necessarily. So if FDA deems it NSE, here's what the regulation says. A regulated device may not be marketed in the U.S. until you receive the letter declaring that it's substantially equivalent. If the device is not substantially equivalent, you can resubmit another 510K with new data. That's usually not my recommendation, at least not yet, because we need to know exactly what is the problem, why is it not substantially equivalent. We can request a Class 1 or Class 2 designation through a de novo, but if you're going to go the de novo route, you should have found out that long ago. You should have not gone through a 510K and have it rejected. You can file a reclassification petition. You can submit a PMA. If that's the case, you've made a huge mistake if you're in the Class 3 universe. But bottom line, not substantially equivalent does not necessarily mean it's not substantially equivalent. It may mean that you just haven't proven your case that it's not substantially equivalent. Just like in the law, not guilty does not necessarily mean innocent. Not substantially equivalent does not necessarily mean not substantially equivalent. And I get calls from companies frequently, our device was NSE from FDA, now what do we do? Well, my first question to them is, do you really know that it's NSE? In other words, do you agree with FDA's decision, or do you want to go back and try to argue that case more strongly? Bottom line, as I've said before, not substantially equivalent should never ever happen, but it does happen regrettably a lot. It's an amateur mistake. Is there a dark side to substantial equivalence? Yes. And this is what's being generated by all of the press recently when it comes to the articles and the bleeding edge and so on. And so to wrap this up, if your goal is to mitigate regulatory burden, in other words, minimize time to market, cost, risk, and so on, my advice is very simple. Design your device in terms of labeling and technology to be as similar as we possibly can, maybe even identical, to your predicate. From a regulatory perspective, that's exactly what we want to do. However, does this encourage copying? Is that the academic equivalent of plagiarism? I'll leave that as a rhetorical question, but remember, you do have an alternative. You do have the de novo. We'll skip that. And finally, let me wrap it up with just this last part here. What's new in the 510K and substantial equivalence world? Some people are probably familiar with some of the chatter now about the proposed 10-year rule that I mentioned earlier, and that is only allowing predicate comparisons to be made to devices that were brought to market within the last 10 years. I personally am against that. I think that's micromanagement from FDA, and I think that that should be up to us to do. It's not a new idea. This is an idea that some of us have been discussing for a very, very long time, since the 510K was created in 1976. And I talked a little bit about risk earlier. I do see the beginnings of a new trend just very recently in the last few weeks and month or so, the last few pre-subs that I've been involved with, where FDA does seem to be taking a more literal interpretation to the risk requirements, something that has never happened in the past, but it perhaps might be a change now, and I suspect some of the audience might want to ask some questions about that. But bottom line, if this turns out to be true, then don't be surprised if we see fewer 510Ks in the future and more de novos. But before anybody gets upset about that, I would argue that perhaps that's a good thing. Time will tell, but remember, you've heard it here first. Remember, as I said earlier, regulation is all about the interpretation of words and our ability to defend our interpretation. The words have not changed literally at all since the 510K was created in 1976, whether we're talking about substantial equivalence or risk. But what has changed, and what is still changing, is people's interpretations of those words. What do those words mean? And that will continue to grow and evolve in the future. So have you had enough? We've talked a lot about the 510K and substantial equivalence in the last several minutes. I'll just end with this final thought, and then we'll take some questions. There are a lot of regulatory consultants out there, but there are very few good ones. So how do you become a good one? If that's your goal, learn when to follow, but more importantly, learn when to lead. If it's to my advantage to follow in somebody else's footsteps, then I'll be the first to do that. But if it's not to my advantage, or if it's not possible to follow in somebody else's footsteps, then I'll be the first to work with the FDA to carve out a new path. Because if you're following in somebody else's footsteps, there's one thing I can guarantee, and that is you'll never go anywhere new. Or put another way, a person who wants to lead the orchestra must first turn their back on the crowd. Regrettably, there are not enough people in our industry who are willing to do exactly that. Those are just some high-level thoughts on the 510K and substantial equivalence. We have a few more minutes for questions. John, I'm sure we probably got lots of questions from the audience. At this point, Why don't we take some of those questions?
Yeah, absolutely. And folks, join me in giving Mike a round of applause. I know you may not hear it, Mike, but I'm sure everybody on today's webinar is super excited. Folks, I just want to remind you that the information you just got from Mike was completely free, and this was something that was jam-packed into about an hour and 20 minutes. Yes, plenty of questions about will you get a replay, will you get a copy of the slides. All that information will be coming to your inbox probably later today, Friday at the latest, and there will be some bonuses in there, so be on the lookout for that. But Mike, thank you so much for that. So let's dive into, we got time for a couple of questions. Let's see if we can pick one to dive into. So this comes from Lucinda. Lucinda's question, does this first time rejection include the time with the RTA, or is this after it passes RTA?
That's a good question, Lucinda. It could be either or both. So for those that are not familiar, the RTA, or refuse to accept, which FDA has put out a couple of versions of this guidance in the last few years, basically a laundry list of all of the parts of the 510K that FDA is expecting to see, the different sections, to make sure that the information is there, to make sure that the signature's in place. So bottom line, if a submission is rejected as part of administrative review because of an RTA issue, that is 100% the company's fault, and that should never happen. On the other hand, if a submission is rejected by FDA on scientific review, this is when the reviewers look at the substance of the submission, the testing methods, the statistical analysis, and if the reviewers have a disagreement with, for example, how you interpreted your data, how you analyzed your statistics or something, then that's FDA doing their job, and this is when the company and the FDA have to work together to try to resolve that. So bottom line, it's a good question. The review process is a two-step process. The first is the administrative review, where the FDA basically makes sure that you have all of your required components in place. And then the second is the substantive or the scientific review. Both are very important, obviously, but in my opinion, as a professional biomedical engineer, it's the scientific review that is much more important than the administrative review. Why? Because there are a litany of factors that will affect the safety and efficacy of a medical device. But I guarantee one of them will never be, what form did we use to present that information? And as I get as I've been playing this game now, John, for going on 30 years, sometimes it's a little frustrating when I run into people, both in companies as well as at the FDA, that seem to be more focused on the forms that they're using rather than the content of those forms. But that's just me.
Yeah,
Go ahead, John.
no, really good point. So a couple folks have asked about the 3-bucket approach to risk. Folks, you can reach out to Mike. His contact information is on screen. You can also go to www.greenlight.guru. You can go into the resources tab and check out webinars that we've done in the past. Mike did a webinar on this topic. Gosh, I don't remember exactly when, but a while back. But that is available. All the webinars that we ever do on Greenlight are always available after the fact, free and on demand. So go there for that. So Brian asked a question: how much time does an additional review cycle typically take?
An additional review cycle? I'm assuming, John, he probably means if you make a submission and it's kicked back.
That would be my guess too.
Okay, unfortunately I can't give you any statistics off the top of my head. I suppose you probably can find something like that in the MEDUFA quarterly statistic reports that are on FDA's website, and I think it's in the handout for the webinar. But it's a little difficult question to answer, Brian, because it depends on the nature of the questions and how many questions there are. So I'm not sure how to answer that in a general sense. I will say this. I think that one of the most poorly written parts of medical device submissions is the device description, and here's why. Because the vast majority of questions I get back, or I see coming back from reviewers, are indicative of the fact that they don't understand our device, how it works, what it does, and so on. And in my professional opinion, it's incumbent on us, the company, to make sure the FDA understands our device, not the other way around. And so because we get so many of these questions, it's indicative to me that the device description is not written very well. So the advice that I give to companies is very simple. We all are used to thinking about measuring the efficacy of our medical device, but never measuring the efficacy of our submissions, and in this particular case, the device description. Take your device description and give it to somebody who's not familiar with your device and ask them to read it, and then literally yank it out of their hands and ask them to describe to you what they just read. If they paint a picture that looks like the device that you have under development, then great, you're communicating. But if they paint a picture that looks totally different than the device that you're developing, or worse, they're so confused that they can't paint a picture at all, you're not communicating. So a lot of this advice that I give to companies, John, to me, it's common sense, but unfortunately, perhaps common sense is not as common as we would like to think.
Yeah. All right, so Mike, I'm going to combine a couple of questions that are somewhat similar in nature. These come from Ramit and from Kevin. And the first part of this is the definition of substantial equivalence from FDA appears to be different from EU MDR and Australian TGA. And then kind of the second part of that, FDA defines substantial equivalence as not raising new questions of safety and efficacy. And sometimes uses the word different questions of safety and efficacy. So I thought those were somewhat similar. So how do you respond to those?
Yeah, it's two great questions. Thank you for asking those. So first of all, in terms of substantial equivalence in other parts of the world, whether it's EU or what have you, that's a bit of a loaded question because most other places in the world do not recognize the concept of substantial equivalence. As a matter of fact, some of the other countries that I work with, like Health Canada, for example, they're not keen on substantial equivalence at all. So it's a little bit of an unfair comparison, I think, substantial equivalence, definitions in different parts. But more importantly, the second part of the question about differences, raising questions of differences of safety and efficacy. This is a little bit what I talked about earlier, John, when it comes to the interpretation of the risk requirements. I would challenge anybody to give me two medical devices that are on the market today, both under the 510K, where one was brought onto the market using the other as the predicate, when there are absolutely no technological differences and no changes in risk between those two devices. Perhaps there's an example out there, but as a PhD in biomedical engineering, I can't imagine that two devices were exactly, literally the same, and that the risk profiles for both of them were exactly, literally the same. And this is what I said earlier, the regulation has never in the past been interpreted that literally before. But today, for a variety of reasons, that might be changing. John, do you have thoughts on that?
No, I'm in alignment with that statement. I mean, risk is certainly an area where it's something that we need to do a better job. I think we as industry can do a better job of those activities. You and I have talked quite a few times, Mike, about this seems to be, and you mentioned it today, an important area for submissions these days too. So do yourself a favor on that. Ramakrishna has a comment, and I can handle this one. For pre-submission, is there any fee chargeable or by FDA? Ramakrishna, pre-submissions have no user fee associated with them, and kind of sort of related to user fees.
I would just add one word to what you just said, John. No user fees for a pre-sub yet. Give Congress some time. Give Congress some time. Last year, there were over 2,300 pre-subs done at FDA. Give Congress a little time. That might change.
Which kind of leads to probably the last question that we'll dive into today, and it's on de novo. But first, Kevin makes a comment. Of course, the FDA wants more de novos. The user fee is $25,000 and $97,000. But the question comes from Mark is, why is de novo better for marketing purposes?
Well, it's a great question, and not to be redundant, but I was fortunate to give a webinar for Greenlight on the de novo as well, so we can point you to that. But the short answer to your question is that there are some very significant competitive advantages to the de novo over the 510K. One of them is labeling. We talked about substantial equivalence today, and in order to show substantial equivalence for labeling, you need to be as close as you can to your predicate. In some cases, that's an advantage. In other cases, it's not. One of the big advantages of the de novo is you're starting out with a blank slate, with a blank canvas in terms of the labeling, and you can paint onto that canvas literally anything that you want, anything that you can support, obviously, but anything that you want. And So again, I know we're coming up to the end of our time, but I give a lot of examples in the de novo webinar of how a de novo can actually be a better choice for a company than a 510K. I would suggest taking a look at that or sending me an email. I've got some articles that I've done on the de novo as well.
All right. Well, Mike, do you have time for one more question? Because I'm kind of curious about the answer for this one. This question comes from Sang, and Sang asks, is software as medical device FDA 510K increasing, and how technically knowledgeable are FDA regarding software?
Well, the second part of the question I'm hesitant to chime in on. I would like to think that FDA would be technically knowledgeable on whatever it is that they're reviewing, whether it's software or a physical device or what have you. But I also would add that I would like to think that the people working in companies developing these products are equally, if not more, technically knowledgeable.
Right.
But I'll leave as a rhetorical comment. What was the first part of it again, John? I'm sorry.
The first part is, do you see an increase in SAMD 510Ks?
Oh, yeah, again, I can't give you the statistics off the top of my head, but obviously more and more medical devices are software-based. In some cases, the software is the complete medical device. So my guess, and if you have any thoughts on this, John, feel free to chime in. But my guess is that the number of software medical devices for 510Ks is increasing. I can also tell you that a tremendous amount of these are coming onto the market under the wellness exemption.
Right.
Whether they should come onto the market as a wellness exemption or not, that's a different story. And again, for those that are interested, I did a webinar for Greenlight on the wellness exemption as well.
Yeah.
But I think that my guess would be yes.
My guess would be yes too, folks, and I don't know that there's any data to corroborate this. It's just, you know, the types of companies that we work with. It's clear there's an increase of software as a medical device as a standalone product, as well as software being an integral part of a device. And I want you to understand that the 510K process ostensibly does not really differentiate whether or not your product is software as a medical device or a mechanical device or an electromechanical device. The 510K process, you know, the rules, if you will, are for all intents and purposes the same. I mean, how you make your argument, how you make your rationale, how you defend your position, how you address substantial equivalence. I mean, as they say, the devil is in the details.